the pigeonhole principle. So I'm just going to look at the pigeonhole principle. Now the pigeonhole principle states that if you have more pigeons than pigeonholes, then there must be at least 2 pigeons in one, that should be a 1, of the holes. Okay, now think about that. That kind of makes sense, because if this pigeon flew into this one, and this one into this one, and this one in this one, and this one into this one, because we have 4 holes, yet we have 5 pigeons. So I see this as a bit of a fraction remainder problem. We will have 1 pigeon left over. Okay, so and see how there must be at least 2 pigeons in one of the holes? You could have the scenario where all of the pigeons went into one hole. So if all of the pigeons went into one hole, so they all flew into this hole, okay, so you got 5 pigeons in that one hole. You still have at least 2 pigeons in one of the holes. Maybe you might have 1 pigeon in this hole, and 2 in this hole, also 3 in that hole, and 1 in that, and none in the last hole. And all the pigeons have somewhere to go. It's just you have 3 in that, and 1 there and 1 there. But you still have at least 1 of the holes with 3 pigeons. Now, if you load pigeons into one hole, that's anywhere. Like even if you had 2 in one, 3 in another, and 0, 0, or 5 in one, 0 in the others, or 1 in one, 2 in one, 2 in and none in the others, you still have, in all of these situations, you still have at least 2 pigeons in one of the holes, okay? So if you think about that, see that one's got 2, that one's got 5, that one's got 2, that one's got 3. Okay, so another scenario would be have 1 pigeon in each hole, and there's 1 pigeon left over, and that pigeon, so if we've got all these matched up to a hole, that pigeon can choose between 4 of them, but you will still have at least 2 pigeons in one hole. So when you're working out this, what you need to do is you need to get your choices that you have. Your choices is your 4 holes. So what are your choices? And with those choices, if you add 1 more, this is when you have it, when you're looking at least 2, if you have 1 more, then you will have at least 2 pigeons in one hole. Okay, so have a think about this. If I had another scenario and I didn't have 4 pigeons, and say 4 holes and 5 pigeons, let's say I have 6 holes, and then we have extra pigeons. Actually, let's just have 6 pigeons. So if I had 6 pigeons, that would mean that there'd be 1 pigeon would fly into each hole. So that doesn't meet the scenario of having at least 2 pigeons in each hole. I would have to have more than 6. So as soon as I start having more pigeons than the 6, so I've got all these pigeons, they're actually legless at the moment. So once you've got all of these pigeons, you would need to get 1 more than 6 in order for you to have at least 2 in one of the holes. So if you get your choices and then you add 1, then you will have at least 2 pigeons in one hole. That's the maximum number that you would have, 1 more than the number of choices. So if you're looking for at least 2 in one hole, you would just have to do the choices plus 1. So let's look at this scenario. We're picking out those ice blocks for the class of 17, and there are 10 different flavours. Now, just correct my spelling there, flavours. Prove that you would need to pick out 11 ice blocks. So you'd need to pick out 11 ice blocks before at least 2 people will have the same colour. So what are your choices here? So we're interested in who has the same colour, okay? So whatever you're interested in, that'll be near the at least 2 people. That will be your choices. So the number of your choices will be the same colour. So the colours are your choices. And you have 10 different colours, so you have 10 different choices, okay? Now, the people are your pigeons, right? So you have 17 people. So there's my 10 ice block colours, 1, 2, 3, 4, 5. And if I'm going to choose a different colour for each one, so then that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then my 10 colours. I would just need to choose one more, and then someone would have to have the same colour as the other people. So there are 10 choices, and if you do +1, once you choose 11, as long as everyone, the first people, all have a different colour ice block, so that's 10 ice blocks, then the next person, that would be the 11th person, would have to have one the same of the other. And the same scenario as I was saying before, you could in fact have everybody having the same ice block, but that still matches this statement. At least 2 people have the same colour, even if you had all 17 with the same colour. To get at least 2, the least amount that you would have to pick, so the smallest amount that you would have to pick for 2 people to have the same colour would have to be 11. Now, I guess the statement here said before at least, it's really before you can be certain. So you can be certain, really confident, that at least 2 people have the same colour. And if you would be certain of that if you drew out 11 ice blocks. By the time you gave out 11 ice blocks, then you could be certain that at least 2 of them would have the same colour. So when you're doing at least 2 with the same colour, or being certain that at least 2 have the same colour, then you're always putting 1 into each pigeonhole. So there's always 1 in each pigeonhole, and then you'll have a leftover. So for example, even if we had 5 holes, so we have 5 holes, so 5 choices, and then we have so that's 5 of them, and we have 9 pigeons. That means that the least amount would be 1. If you want to have at least 2 of the same colour, that means if you did 9 divided by 5, so you get 4, so you get 1, sorry, you can't do my maths there. You get 1, and you have with a remainder of 4 left over. So if you put 5 of them in one hole, once you get to the next one, which is 5 plus 1, so once you get to the 6th pigeon and you go to place the 6th pigeon, you only have to go 1 more pigeon from that remainder of 4 and put them in, and you would have at least 2 pigeons in one of the holes. Okay? If you were looking at 3 pigeons in any of these holes, so say we have 5. So we have 5 choices. If we want to have at least 3 in there, then how many would we have to draw here? So if you think about that, if you want to have 3, 1 less than 3 is 2. You would need 2 in each hole. Okay, so this is at least 2, so you do 1 less than 2 is 1. You would put 1 in each hole. So whatever you're doing at least, if you take 1 away and you put the 1 in that hole, so this one we want to put 2 in each hole, so that when I go for the next one, it's going to put 3 in at least one of those holes. So what's the smallest number you would have to draw out so that you have at least 3 in a hole? Well, you see how what we do here is we have 2 plus 2 is 4 plus 6, 8 and 10. There are 10 all together there, 10 pigeons, 2 in each hole. And if you went one more than 10, that would be 11. So basically what you're doing there is the first step is if it's at least 3, you're taking the 3 minus 1, that's the extra one, which is 2. So you know it's 2 in one hole. It is your choices minus 1 less than the at least. So if you do the at least and you do 1 less than that, you do 1 less than that, and that will give, and then what you need to do is add 1 more, because 1 more would be your extra pigeon. See, so your choices here is 5 times 2, that would be 10 altogether, because you've got 2 in each hole. And then if you add 1 more, then you're going to end up 3. You're going to be certain that there will be 3 in one of those holes. Okay, so it's like a sharing game. So if you want at least 5 with the same colour, and we're still doing the same number of holes, so we're going to have 1, 2, 3, 4, 5. So we have 5 boxes. So that means my choices to put them in was equal to 5. Okay, if I take 1 away from the 5, I get 4. All right, that means that I go 5 times 4 is 20. It means I'm going to put 4 in each hole. So far, if I'm going to have at least 5 in one of the holes, I will need 1 less in each of the holes. So then 4 times 5 is 20. If I add 1 more, once I do the next one, I could add 2 more. But I can be certain that once I take 1 more than that 20, which is 21, and put that into one of the holes, then I will have at least 5 pigeons in one of the holes, which is 5. Okay, now in the 2020 HSC, this one came up. So let's have a look at this one and let's figure out what's the number of choices. So to complete a course, a student must choose and pass exactly 3 topics. So they're going to pass 3 topics. But there are 8 topics altogether. All right, so last year 400 students completed the course. Explain using the pigeonhole principle why at least 8 students passed exactly the same 3 topics. Okay, so your choices, you have 8C3, that would be your choice, which is 56. Now, if we want at least 8 students, then if you take 1 away from 8, then you would have 7 in each of the 56. Like if I did 56 choices, so that's 56. And what I'm going to do is I'm going to put 7 in each of those spots. So 7 students would have passed 3 of those courses. So now if I do 56 times 7, so if I times that by 7, I end up with 392. And because 392 is less than 400 students, then you can actually be certain that if you've got 7 in each hole, once you get to the 393rd student, there will be at least one of these holes where you will have an 8. So you will have at least 8 students who passed exactly 3 of the same topics.